Hi y'all. So today I'm going to do a quick overview of bond line formula in organic chemistry. So up till now you've probably seen molecules drawn with every single atom and every single bond like in a Lewis structure, something like this. But for organic chemists, that sort of becomes unrealistic because we have really big molecules with really big lots of carbons and lots of hydrogens. For example, a common one we see is cyclohexane. So cyclohexane has 6 carbons in a ring. And each carbon has 2 hydrogens, and so that's a lot to draw. It takes up quite a bit of time. And so organic chemists have made sort of a shorthand notation where instead of drawing in every carbon, we assume that every vertice, or I like to say bend or end of a line, is a carbon. So instead of drawing all these out, we can do a shorthand where essentially every single one of these angles we assume is a carbon. So I've drawn them in for you here, but actually what it looks like is this. So what this means to an organic chemist is there's a carbon here, and a carbon here. So every vertice indicates a carbon. And then here, for example, we have 1, 2, 3 hydrogens, 2 hydrogens here, and 1, 2, 3 hydrogens there. Well, it took me a while to draw in all those hydrogens, right? If we have really big organic molecules where there's like 20 or 30 carbons, it's going to take even longer to draw those all in. So what we do instead is assume that the octet rule has been filled unless otherwise indicated by a formal charge. And I have another video on formal charge if you want to go watch it. But essentially, we assume that we have every carbon wants 4 bonds because if a carbon has 4 bonds, then each bond made up of 2 electrons gives the carbon 8 electrons total. And that fills what we call the octet rule, that electrons or atoms want 8 electrons to be happy or to be satisfied electronically. So we assume that each one of these carbons has enough hydrogens to fill in the 4 bonds that it needs. So this carbon right now, you only see 1 bond to another carbon. So the 3 hydrogens right here are implied. This carbon has 1, 2 bonds to other carbons, so the 2 hydrogens right there are implied. And this carbon has 1, 2, 3 bonds to hydrogen, so the 3 hydrogens right there are implied. If we did that same principle here to this cyclohexane, we could just draw a hexagon. And it's assumed that every vertice here, every bend or end, has a carbon, and that each of those carbons has enough hydrogens to get it to 4 bonds. So if this carbon has 2, then we assume 2 implied hydrogens right there. This carbon has 2 lines, we assume 2 implied hydrogens right there. So that's kind of the basics of bond line formula. Something else to note about bond line formula is a lot of times we do these up and down lines because that is actually how molecules look in their tetrahedral arrangement if there's 4 bonds to them. So you may remember learning in Gen Chem about the different shapes that molecules can have and how if you have 4 electron domains, it looks like a tetrahedral. So here is a tetrahedral shape with a 109.5 degree angle around it. But if you arrange a line of carbons in that tetrahedral shape and they're bonded to one another, they bend like this. And so for our assuming that there's a bend and end at every single vertex or a carbon at every bend and end is because that is actually the bend shape is what carbons actually look like when they're bonded. So you can see if this black represents a carbon, there's a carbon here, and then this black represents a carbon, this black, that black, that black. So right here we've drawn a structure that assumes the same structure as a model, for a carbon actually represents. And then sometimes in organic chemistry, we'll take it a step further to try to show that tetrahedral arrangement by indicating that some molecules are coming towards us, like this red one, and some molecules are going away from us. And when we do that, we would draw the one that's coming towards us on a wedge, a solid filled in wedge. So I'll just write like red right here is coming towards us. And then the one that's going away from us, we put on a dashed line and say white, for example. So that's just a quick overview of bond line formula and finding implied hydrogens. And then you can combine that with formal charge to identify any implied hydrogens or lone pairs that might not be clearly drawn in. I guess I did also want to say you don't have to draw any hydrogens unless they're attached to heteroatoms. So heteroatoms is anything that's not carbon, but for organic chemistry, it's typically nitrogen, oxygen, fluorine, sulfur, other halogens like chlorine, bromine, iodine. Those are the big ones that we see in organic chemistry. We don't see very many others. But if you see those and a hydrogen's bonded to it, you do have to draw both this heteroatom in and the hydrogen. But I wanted to focus mostly on the hydrocarbons, hydrogens with carbon, because that is a thing that I find students sort of get caught up on. So that's just a quick overview of formal charge. Hopefully that's helpful to you. Of bond line formula, not formal charge.